I have this all going and then it didn't save on me. So I'm going to try this one more time. So now that we've talked about the properties of logarithms, I want to solve some equations with logarithms using those properties that we know, using everything we know about logs and exponents. So here's number one. Okay, so here's my first example. So I have log of x minus 5 equals negative 2. And again, that invisible base is going to be base 10. That was invisible. I wrote it in. So log of x minus 5 base 10 equals negative 2. If I rewrite that in terms of just exponents, I know what that means is base 10 to the negative 2 power is going to give me x minus 5. Okay, from here, it's pretty simple for this one. So I know that 10 to the negative 2 power is just 1 over 10 squared. And 1 over 10 squared is just simply 1/100th. So I have 1/100th equals x minus 5. And right here, I just wrote 1/100th, rewrote that as a decimal. So 1/100th equals x minus 5. And it's a very simple equation to solve from here. So now I'm just adding 5 to both sides. And I get 5.01, or 5 and 1/100th is equal to x. Right? Okay, so let's try this one. Let's try number 2. Here, my equation is 2 times the log of x equals 1 6/10. Right? Well, if I just simplify that, like we did in class the other day, if I just simplify that by dividing by 2 using some inverse operation, I'm going to have my next step. I have log of x equals 0.8 or 8/10. Now again, I wrote in this invisible base 10. So now I have, in terms of just exponents, I'm going to take my logarithmic form and turn it into exponential form, and I have 10 to the 0.8 power, right here, is equal to x. So now all I need to do is put that in my calculator, 10 to the 0.8 power, and I get x equals 6 31/100. All right, number 3 just gets a little bit more involved here when it comes to simplifying and solving for x. But I want you to keep in mind this whole time your change of base formula. And does this remind you of change of base? Right, think of that proof that you watched for change of base. So I have 17 plus 1.25 raised to the x power equals 30. Now again, I just want to simplify this so that I just have my base and my exponent. So if I subtract 1.25 from, or sorry, not 1 2500, if I subtract 17 from both sides, I'm left with this 1 2500 raised to the x power equals 13. All right. So again, remember change of base. So some of you might want to just go directly to change of base. And if you're really comfortable with change of base and you know change of base, go for it. I'm going to do that middle step. Again, this is like your proof of your change of base formula. Okay, so I have, I'm going to take the log of both sides. I can do that if I do something to one side, I have to do something to the other side, right? That property of equality. So I'm going to take the log of 1.25 to the x power equals the log of 13. Okay? So I took the log of both sides, and now I can simply divide by the log of 1.25 on both sides to get my x alone. So I'm dividing by the log of 1.25. And I end up with x equals 11.49. So again, this is like using your change of base formula. Log of 13 over log of 1.25. If I look at this right here, right? I have my base 1.25 on the bottom, right here, base goes on the bottom, and then log of 13 there on top in the numerator. All right, so we're going to switch gears a little bit here. We did a couple of these in class, but I'm going to take a look at it again. In case you didn't quite catch it that first time, let's look at it one more time. So I'm assuming here that the log of 5 base 6 is equal to q. So I want to write log of 5 6, erase those dots here. I'm going to erase a bunch of this stuff that I had the first time around. All right. So I have, I'm going to write this in terms of Q. I want to write log of 5/6 base 6 in terms of Q. Well, if we remember our quotient property, so think exponents for a second. When I divide exponents, or I'm sorry, when I subtract exponents, what am I doing? It means that I have a division problem with exponents, right? Because I have, for example, x to the 5th over x to the 6th. It's just the same as x to the 5 minus 6 power, right? We know that property of exponents, so we can apply that to logarithms as well. So in other words, I have log of 5 minus log of 6. Okay? All right. So then I subtract my exponents when I divide. All right, so I have log of 5 base 6 minus log of 6 base 6. Well, I know, if I look back up here, log of 5 base 6 is equal to Q. So that I can just write in terms of Q. That is equal to Q. All right, and I have minus. I have log of 6 base 6. So let's take that out here for a second. So what is that? If I rewrite that in terms of exponents, I'm saying 6 to some power is going to give me 6. Well, if I take a look at that, what is the only thing that x could be? 6 to what power is 6? Well, obviously, right? If I raise 6 to the first power, I'm going to get 6. So that x is equal to 1. So what do I have here? I have log of 5, 6. Base 6 is the same as Q minus 1 if I'm writing that in terms of Q. Now we're going to finish this off with one more of these kind of fun problems here in terms of Q. So this time I have log of 30 base 6 in terms of Q. Okay, well, why did I do this? Why did I do log of 5 plus log 6? So if we think back to our product property, right, if I have exponents and I have x to the 5th power times x to the 6th power, what do I have? I have x to the 5 times 6th power, or x to the 30th power, right? Wrong. Do I multiply exponents? When I multiply powers, when I multiply those x's, am I really supposed to multiply those exponents as well? That's not product property. A product property doesn't have me multiplying exponents. Product property has me adding exponents, right? Multiplying exponents is going to be my power property, not my product property. So, whoops, I have 5 plus 11. What I meant to say is 5 plus 6. So hopefully you caught that the first time. So in other words, x to the 11th power, right? My product property actually has me adding my exponents, okay? So over here, if I have log of 30, that means what I did was I multiplied 5 by 6 to give me my log of 30. So what I have is now log 5 base 6, again, equal to Q, as stated up top. And like in the last problem, log 6 base 6 is equal to 1. In other words, 6 to the first power is equal to 1. So in terms of Q, I have log 30 base 6 is the same as Q plus 1.